channel Balbigyan Bharti, and here is your mentor Avilash Sarkar. We are progressing on speed, time and distance problem solving session. There we have reached till problem number 22. Now we will do 23 onwards. So the problem 23 for you. A man travels from A to B. A man travels from A to B at speed of at speed of 36 kmph. Okay, 36 kmph in 74 minutes. In 74 minutes, and he travels a distance from B to C and travels a distance B to C with speed 45 kmph in 111 minutes. Find average speed for whole journey. Find average speed for whole journey. Okay, so the solution comes, the points are A, B and C. Between A and B the distance is how much is not given, and there is a distance. What are the information given? The speed for this is 36 kmph and for this it is 45 kmph. The time taken here it is 74 minutes, here it is 111 minutes. Okay. Now you have to find the average speed. So as the movement is linear, means they are moving in the same line, this is progressive travel. So average speed will be what? The initial speed is given, distance is not given. This initial speed is after speed is given, distance, the time is given. Okay, so let's say this is your distance, means d1, this is d2. So for that average speed, the speed would be what? Total distance upon total time. This is the only formula for calculating average speed. The total distance is d1 plus d2 by total time is equal to t1 plus t2. What is d1? d1 is equal to 36 into 74 upon 60, and that of this is equal to 45 into 111 by 60. Speed into time, total distance divided by the time, 74 by 60 plus 111 by 60. Okay, now you can calculate this easily yourself. So ultimately 60 all will cancel, so this is 36 into 74 60 I have done only to convert into hours. Okay, but effect of 60 is not coming because numerator denominator both way it is coming denominator, ultimately that will be cancelled. So for further any problem you need not to convert in case, as because this is the ratio of two things where the conversion will not affect the calculation. So this is 74 plus 111. Now this becomes 185. This is 36 into 74 plus 45 into 111. This is the case. So now you can solve yourself. I am not going to solve it. You have to find the way so that you can solve it in minimum with minimum effort. Okay, but ultimately whatever result you find, that will be the average speed. So now I will move to the problem number. Now problem number 24. Sorry. So number 24 says a car travels some distance at a speed of 8 kilometer per hour and return at a speed of 12 kilometer per hour. If the total time taken by the car is 15 hours, then what is the distance? What is the distance in kilometer? Okay, so this could be solved with a very analytic method or with some concept. So first case we'll solve it with the analytic method. What we will assume that the distance between this A and B may be the 2 points, B, D let's say, and the time taken for the forward journey is T. The reverse journey it will be 15 minus T obviously. The speed is 8 for this case, this is 12. So as the distance is, I will not assume D because D is no need to be taken. Why I am saying? Because the forward journey A to B is, if it is A D, B to A, for the return journey also to be. So forward journey, what is the distance with time and the speed, we can represent the distance. The distance is 8T, T I am taken the forward journey time. For the reverse journey is the same, speed into the time. If I equalize those, because both case it is denoting the distance and the distance is same, A to B and B to A are same. So from there, if I reduce it, so 2T is equal to 3 into 45 minus 3 into T, so 5T is equal to 45 and that T is equal to 9. So that forward journey is, time is equal to 9, so reverse journey is equal to 6. Now D, the distance is equal to forward journey 8, speed into 9, so that is equal to 72 kilometers. This is the one way of doing that. Other way, in case 2, how we can find, because from A to B, whatever with distance covered, B to A covered the same distance, so double of the distance. If I say this is D, so reverse journey also is D. The total distance 2D is equal to what? Average speed into total time. This also can be said. This also can be one of the method of doing that. In any journey, if there is a different kind of speed is being maintained and there is a different total time and there is a complete journey time is being given, then we can use that for the total journey is equal to the average speed for that total journey into the total time taken to complete that journey. This is also one kind of. So average speed, how do you find? Average speed is equal to 2 into S1 S2 by S1 plus S2. This is the formula for where that forward journey and reverse journey length is same. This is a specific case where the forward and reverse journey length is same. How do you do that? Let me prove it. If that forward journey is d, so what is the average speed? Total distance upon total time. So what is total distance? D for forward journey, D for reverse journey. This is total distance. And what is the time for forward journey? D upon distance upon the speed 1 S1, and for reverse journey D S2. This is the only case possible. Now this is what 2D upon, if I take D common, this is 1 by S1 plus 1 by S2. Now D cancelled out. This if you do LCM, so 2 S1 S2, 2 into S1 into S2. In the numerator S1 plus S2 will be there. So this is the formula I am using here. Okay, into the total time. Now if this is the case, then 2 into S1 is 8, S2 is 12, S1 and S2 to 8 plus 12 is equal to 20 into 50. This will be the equation. This is equal to 2D. Now 2 cancelled out. So ultimately D is equal to this one. Now 5 3s are 5, 4s are 4, 3s are 3 3s are 9, 9 8 72. See the same result I am getting. The D means the distance. So this is in one shot I can get the result. So there could be two methods. Both you have to understand. The earlier method is very analytic and it is very easy to compute. This you have to use your brain, but this average speed formula is applicable where the distance for the journey for forward and return journey is same. Remember that. If it is different, then you cannot use this formula. Okay. Then the first one, the analytic method, will be helpful where you can manipulate. There also I have used the concept of equal distance. That's why I have equalized the distance. 8 into t, whatever will be the distance, 12 into 15 minus t will be there. So that concept. But analytic method, if you do, there is a chances of less failure. But here, if your concept is wrong, you will end up with a wrong result. Okay. So this is number 24. Now I will move to the problem 25. A 1200 meter long train, crosses a tree in 120 seconds. How much time will it take? How much time will it take to pass a platform 700 meter long? Now this kind of problem I have already solved several, so I will not going to solve. I will leave it with you. Kindly try. This is the easiest one. You have to find what to be calculated to compute the second part. So this I am leaving to you. I will not show the solution for that. This will be a task for you. Just this you can say that the task homework or task, whatever you can say, you do it yourself, and if it is possible, just write the answer in your comment box so that I can check whether you have done right or not by seeing the answer, or if you can give me the complete solution also in comment box, that will be very good for me, so that I can understand the people are at least have something to learn from me, and I have learned. Okay. So I, on that note, I leave it to you to solve at home. Okay, now I'll move on to the problem number 26. A car complete a journey in 7 hours. A car complete a journey in 7 hours. Half of the distance with 40 kilometer per hour, and other half at 60 kilometer per hour. Then the distance traversed. Now again, this is also very known kind of problem. A car completed journey in 7 hours, half of its distance with 40 kilometer and other half in 60 kilometer. Now just few minutes back I've solved a similar problem, and this problem is based on the same concept. Again I'm leaving it to you for homework. Kindly try and post your answer in the comment section with the complete solution. If it is possible for you, just post it in your comment section. Okay, I will be very happy that at least people are attentively seeing my classes. Thank you. So I will move on to the problem number. So there are two tasks for you, 25 and 26 I am leaving for you, and this is 27. A thief was spotted. A thief was spotted by a policeman, man exactly, from a distance of 220 meter. From a distance of 225 meter. So now you can guess what could be the direction of movement of the thief when he can see a policeman. That's why this direction is not given. This is an obvious thing to be understood. When the policeman started the chase, the thief also started running. The thief also started running. If the speed of the thief was 11 kilometer per hour and that of policeman was 13 kilometer per hour, how far would the thief have run before the policeman caught him? Before the policeman caught him. So as I said, there is no ambiguity that thief will try to move away from the police, and police at the same time will chase the thief. So let's say after some point the police and thief met at a boundary line where both will reach together. Okay, as because police is chasing thief, so to catch him only, and he might increase the speed to catch, and after some time he catches. This is the fact. So now a thief was spotted by a policeman from a distance of 220. So initial distance was 225 meter. When the policeman started the chase, he has started by seeing the thief at 225 meter and just started seeing him. Thief also started moving. Speed of the thief was 11 kmph. The thief is moving with the 11 and the policeman is moving with the 13. So his speed is obviously high, so he will catch after some time. How far would the thief have run before? So this the distance, let's say x, to be calculated. So in the time, if you assume that police have catched the thief, so the time taken thief to move the x distance with the speed 11, in the same time the police can have to move 225 plus x with the speed of 13. So for them, when they are meeting at point, the time is to be same, because they are running for the same time, but distance is different. So time is difference, that means the distance upon the velocity for the thief to move will be equal to 225 plus x divided by 13. So this is the speed, so their time has to be matched. So from there you can easily calculate the x. So this is the x, and what is the requirement? How far would the thief have run? So this is the x is required, and that you will able to find it from this equation. I am not going to solve it, you solve it for yourself. Okay, so number 27 has gone. Now I will end up here, and in next class I will move on to the problem number 28. Okay, so thank you for now.